Hello class, this is Mr. Sutton, and today we're going to be talking about solving logarithmic equations and solving exponential equations. So first we're going to talk about solving logarithmic equations, pretty similar to what we did last class, but this time we're actually given an equal sign. So there's three different things we can solve for. We can solve for the base, we can solve for the argument, or we can solve for the exponent. But you'll have to remember how to rewrite this as an exponential equation. That should be in your notes from last class. So I'm going to rewrite this as an exponential here. So this will be x to the third power equals 512. Now here we have an equation that we can solve for x by taking the cube root of both sides. So that'll be x here, and then the cube root of 512, which is the same thing as 512 to the 1/3 power. So you can plug that into your calculator. 512 raised to the 1 divided by 3 power, and you should get 8 for that one. The other thing you can do is kind of a guess and check thing from this step. X to the third equals 512. You can check different numbers and raising them to the third power and see which equals 512. So you might start with like 6 or something, and 6 to the third power is 216. So then go up from there, right, until you get to the right answer. So that's another way you could solve this. So here's another type of problem. So the previous one, we were solving for the base. Here we're solving for the exponent. So these are similar to the ones we had last class, but it's set up as an equation. So 2 to what power equals 128. These you can also do by guess and check. So if I start with, let's say, 2 to the 4th power, maybe. What is that? That's 16. So I have to raise it. Let's go 2 to the 6th power, 64. 2 to the 7th power is 128. So x has to equal 7. The other way you could do this is by plugging it into the calculator. If you remember from last class, this equals log base 10 of 128 over log base 10 of 2, which this is useful because the log button in our calculator is always going to be log base 10. So you can use this if you do log of 128 divided by log of 2, you should get 7. All right, so that's how you solve for the exponent. Then the other type of problem we have here is solving for the argument. So this one, rewrite in exponential form, that would be 9 to the third power equals x. This one here, you could just figure out what is 9 to the third power. 9 raised to the third power equals 729. So 729 would be your final answer for this one. All right, so those are the three different things you can solve for logarithms. Either solve for the base, like this one, solve for the exponent, like this one. These are similar to the ones we did yesterday, or solve for the argument, like this one. Here we're just writing the log equation as an exponential equation. You do not need to solve for x for these. So you would just rewrite it as the base exponent equals the argument. So you just rewrite that and put it in delta math. Same thing here, write the log equation as an exponential equation. You do not need to solve for x. Here we're not given the base, so that means we have to assume that it's 10. So base 10 squared, exponent is 2, equals the argument, x squared minus 3x minus 10. And then, once again, rewrite it as an exponential equation. Here we have the natural log, which is log base e. So our base is e. Our exponent is all of this, 2x plus 3. And this equals the argument, which is 2. So this would be our answer for delta math. And then here, write the log equation as an exponential equation again. This time the base is x plus 2. And then the exponent here is 3x. So we want to make sure we're raising all of the base to this exponent. So you want to put parentheses here, equals the argument 4. Okay, because the base is x plus 2. So all of that is being raised to this exponent. And then here we're solving for the exact value of x. So these ones are a little different here. We are going to want to combine them using the information we learned about logarithms yesterday. We'll have to combine these into one logarithm. So this will be log base 3. Since these are added together, we'll want to multiply the values inside. So 2x times 6 will be 12x equals 3. And then now we can rewrite this in exponential form. So the base 3 to the third power equals the argument 12x. So what is 3 to the third power? We can simplify that. 27 equals 12x. So then divide both sides by 12. We have x equals 27 divided by 12 is 9/4. Leave it as a fraction. But that would also be 2.25. Either answer there. All right, so moving on to this one. Here, once again, we have the same base, so we can combine these into one logarithm. So since they're being subtracted, that would be 5x divided by 2. So now, as exponential form, we would say 2 to the third power equals 5x over 2. And then this is an equation that we can solve for x. 2 to the third power is 8. Then we can multiply by 2 on both sides. Go to 16. Divide by 5 on both sides. So we have x equals 16 over 5. That doesn't simplify any further. And as a decimal, that would be 3.2. So either of these answers would be fine, 16 over 5 or 3.2. And the last section I'm going to show you on delta math. All right, for this section, solve for x rounding to the nearest hundredth. So we have this set up, and it's in exponential form. The thing is, for this one, we can't guess and check because our exponent is going to be not an exact answer. If you do 3 to the third, you get 27. If you do 3 to the fourth, you get 81. So our exponent is going to be somewhere between 3 and 4, but we don't know exactly what. We're going to be rounding to the nearest hundredth here. So how do you find this exponent if it's not an exact answer is the question. So what we want to do is we want to take the log of both sides, and we're just going to use log base 10 because that will make it so we can plug it into the calculator. And we want to get x by itself. So the way we do that is we move this x out in front, turn it into multiplication using our log rules. And then to get x by itself, we can divide by log 3 on both sides. And we get x equals log 78 over log 3, which we can type into our calculator. So let's do log 78 divided by log 3. And you get this 3.965647273. So rounded to the nearest hundred, that would be 3.97. All right. So I just want to note that this is the same basic principle as what we were doing before. If you rewrite this in log form, the way we were solving these before is we'd say that's equal to log base 10 78 divided by log base 10 of 3. Same basic idea. So we ended up in the same exact place. So that's another way you could do this. You can rewrite this in log form and just know that rule that you can change that into that. Or you can do the algebraic way where you take the log of both sides and move the x and then divide on both sides. Either way, you end up in the same place. Let's go ahead and look at one more like this. So again, we want to get it in exponential form first. So divide by 438 on both sides so that you can have just the 10 to the exponent. And then 73 divided by 438 is 1/6. So now we have 10 to the exponent equals our answer. So we can go ahead and take the log of both sides here. And again, we just want to use log base 10 so that we can plug it into our calculator. And we want to get the x by itself, so we'll move this exponent out in front. And to get x by itself, we'll need to divide by log 10 on both sides. So then we have 4x equals log 1/6 over log 10. So I'm going to go ahead and plug this into the calculator here. So log of 1/6 divided, whoops, we'll go out here, then divided by log of 10. So we get this negative 0.778, etc. So I want to take this. I'll just go ahead and copy it because the next thing I want to do is I want to take that and I'll have to divide it by 4, right? So 4x is approximately negative 0.77 something something. So divide by 4 of x equals, so what is that? Can I paste that? Maybe not. Alright, it wouldn't let me paste it in here, but I could paste it over here. So you'll have to write down your answer or paste it somewhere else, but we can do that. So negative 0.7781 512504, and then divided by 4. So we have negative 0.19. As our final answer, rounded to the nearest hundredth. All right. So that is the last one we are going to do. If you have any questions about any of this material, make sure you ask for help during class, and have a good day.